Okay, for this lab, we are going to light ethanol on fire, and that's called combustion. And when we light ethanol on fire, water and carbon dioxide will be produced. So we will light the ethanol on fire, quickly cover it with a container to trap the gas, and the CO2 that will be produced as a product of that combustion will travel from the evaporating dish over to the petri dish with the BTB, and we should see a really pretty color change from green, hopefully, to yellow. Okay, so to set this up, we need 20 mLs of ethanol in the glass evaporating dish and 20 mLs of BTB in the petri dish. Okay, so to do that, you are going to use this graduated cylinder and fill it up to the 20 ml line with your ethanol, and then to the 20 ml line with your BTB. Okay, and if you want to fill it up to just before the 20 ml line and use your pipette to top it off, that would be the only reason that you would need a pipette for this demonstration. So let me fast forward this reaction. I have my 20 mLs of my BTB ready to go. I've got my 20 mLs of my ethanol ready to go. I am almost ready to start my reaction, but what I need to do before I do that is take the mass of both with their liquid inside and record that data on this data table, which is on the back of this lab paper packet. Okay, so I flip it over. I have my before data, which is what I'm going to fill out. I'm going to wait 20 minutes, and then I will do the analysis on the final product after the combustion. Okay, so I take the mass of the evaporating dish with the ethanol on the scale, record that right here. I take the mass of the BTB in the petri dish. I record that right there. All right. Now, I am almost ready to set the ethanol on fire. Okay. So in order to do that, I need to realize I have a plastic container, and fire and plastic are not friends. So I need to get some tin foil. So ask your instructor when you're ready for your tin foil. And what you need to do with a piece of tape is you need to put foil on the roof of this chamber over the top of where the ethanol will combust. Okay, so I'm going to rip off a piece of foil, fold it into a square. I'm going to put a tape dot right there because tape's plastic. I don't want tape to be exposed to the fire. So I'm just going to make tape balls. I'll put a tape ball there, put my foil in. It only needs to cover 1/2 of the container because that's the only side that ethanol will be exerting a flame. Okay, so when I'm done with that, I put this over the top. Okay, there's one more thing that we have not discussed. I want you to take the temperature of the system before and after the reaction. So to do that, you take this thermometer and you put it into the system like that, okay? And you record in Celsius right here. Fahrenheit is American. Everyone else, except I think one other country, uses Fahrenheit. We use Celsius in science. So Celsius, take your temperature. Okay, before you light it on fire, you're almost ready. If you were to look at the side profile of this, there are massive areas over here where the gas, the CO2, can escape. Okay, that will cause major error in our results. So what I want you to do before you light it on fire is create a way to seal the gaps where the Tupperware meets the desk, because that's where gas can escape, and that will cause our readings to be incorrect. So when you get your thermometer in, I want you to find a way to seal the cracks. And at that point, call me over. You will light your ethanol on fire right here. Quickly close the container and let it sit on your desk for about 30 minutes. Okay, and with that, we're going to be able to track the flow of matter in a system and the energy changes that will be occurring in this mini reaction. Okay, just to clarify with the foil work, what I want you to do is turn your Tupperware container down like that, create a piece of tape right here, and on just 1/2 of the container that will cover the evaporating dish where the fryer will be, I want you to put a piece of foil. So then when it covers it, the flame will touch the foil right here and not the plastic. And in terms of sealing the cracks to avoid CO2 vapor to escape, I'm thinking you'll do something like this, where you fold down the sides like that. You don't want any gas leakage. That is the point. So maybe like that. All right.